to measure the very long distance. That means it's a very short, long distance means distance between the two stars or the two galaxies or the two planets. That another measurement is distance between the atoms. That is the shortest distance. So the measurements are used for the to measuring the long distance and the short distance. And parallax method. So now we are going to see the measurement of length in a parallax method. So parallax method means that the actual positions are the go and the apparent position. We are imagining that another position. So it's a method of measuring the distance. So parallax method. So you can take the reference point in a pencil. Pencil is can take the two eyes, left eye and right eye. So reference point and the pencil. So now we are going to measure the length by using the parallax method. So right eye and the left eye. When you are coincide that pencil and that point, that is called parallax. We are placing the two objects in a two different position. But the viewpoints of that eye is like this. So two different positions when you are seeing the two objects. So that's called line of sight. So left eye and right eye. The distance between the left eye and right eye indicating that line of red line that's called basis. And right angle. So see that it's a triangle. For distance between the two eye and the point of the pencil. And another one triangle is produced from the pencil to that object. The image which is also on the surface. So that is left eye and right eye. You can take it at L and R. So using the same method, we can observe the distance between the moon and the earth. So you can observing the distance from planet earth to that other object also. So see that X, Y are the two position of the earth, like two Y, X and Y. So we can able to see the object from the earth. So we can take the sun. So X and Y are the two positions, like our two Y. So we are taking like this. So the distance between the X and Y is the B, that is base of the triangle, basis. So you can see that it's the triangle. So we can take in that's the B. So it's a triangle. See that the angle of the Y, X is beta, X, Y and S is gamma are the two angles. Okay, through that basis. See that's a triangle, that yellow line. The theta indicates the angle. That angle is theta. So now we have to calculate the theta. So adding that all the three angles, beta, gamma and theta equal to 180 degree. It's a total angle of this triangle. So now we have to calculate the distance from the sun from the earth. So the shift position of the object is that the two eyes keeping the closed in a time is called parallax method. That method is used in the triangular method to calculate the value. So now determination of the sun from the earth. So we can take that xs is equal to ys, that is equal to distance d. That is the actual distance of the distance from the earth to the sun. So b by d is very, very smaller than that one value. Okay, so you have to take that angle equal to that radius of the circle. That distance taken as radius of the circle, and distance that xy is taken as a arc or the displacement. The center angle is taken as theta. So theta equal to, so you can calculate the theta value. Theta is the angular solid angle. That angle equal to b by d. So where d is taken as radius, theta is taken as a radius. That's the angle. Or we can write b equal to d into theta. B equal to d theta. Or we need the value of d, the distance. So d equal to b by theta. So we can calculate the distance of the sun from the earth by using the parallax method. So this is the diameter of the planet. So you can measure the two positions like our eye, right eye and left eye. So this is the angle alpha from the position of x. and the same thing we can measure from the point Y also. So alpha is equal to d by d. So d equal to d into alpha. That will give the distance, that is diameter of the planet, where alpha is the radius because that's an angle. So alpha is an angle. So we can, like that, we can measure the diameter of the planet. So this is the other position of the planet to measure the diameter of the planet. So we can measure the same way to measure the diameter. That is the 2 point of the planet. So using that, we can measure the diameter of the planet. So not only the sun, any planet, we can measure the distance from the earth by using the parallax method. So 1 degree equal to 1.75 10 to the power of minus 2 radian, or the next one is these are all the fixed values, that's a constant values. Then 1 minute equal to 2.91 into 10 to the power of minus 4 radian. So whatever that value in radian, we have to convert that into SI units. That's why we are converting these values. 1 minute equal to 4.85 to 10 to the power of minus 6 radian. That is a SI unit. So there is a relation between the radian, degree and the minutes. So using that, we can measure the distance between the two stars. At the same time, we have to measure the length of the atom. By using the vernier caliper and the screw gauge, we are not able to measure the length of an atom. So we require some other object to measure the size of an atom. That is electron microscope, and microscopes are used to measure the distance or the size of an atom. So it also has some limitations. So we are not able to measure the inside that atom. So only we can measure the size of an atom, but we are not able to measure inside that atom. So for example, we are measuring the one molecule, that size of a molecule by using the example oleic acid. That molecule structure is like this. So the oleic acid and is mixed with the 90 cubic centimeter of alcohol. So that is one cubic centimeter of oleic acid, and mixed with the alcohol, it will become a 20 cubic centimeter. The concentration is 1 by 400. So that concentration is reduces. Okay, when you mix it with that alcohol. So we are reducing the concentration of the oleic acid. Right? That is equal to 1 by 400. So that is the density of the jet. So it is a water surface. On that water surface, we are pouring the lycopodium powder sprinkled on the water. So lycopodium powder is sprinkled on the water. It will like a one plain surface, one thin layer is produced on the water surface. So one thin layer. So it is floated on that layer. So thin layer. Above that layer, we are putting one drop of water. Pour one small drop of water means it producing a very thin layer. It will spread it on the lycopodium powder. So why you are doing like this? You are going to measure the thickness of that layer. We are going to measure the very small value. That's why we are doing this experiment. Okay, it's one example. It's not in your book. Just you know that. So using that liquid drop, it's spread in a thin layer on the surface of the water. The diameter of the circle is d. So already we know the parallax method to measure the diameter. So volume of the solution in through the liquid. So when you pour in the 1 cubic centimeter of the oleic acid, that is equal to V into centimeter cube. V is the volume. Volume in unit is centimeter cube. That is the volume of the liquid. So volume of oleic acid in 1 drop of solution. Already we calculated that is 1 by 400. So we multiply this volume. So volume divided by 400 centimeter cube. So volume of oleic acid is true. The value is equal to, see, we are going to calculate the total volume of the thin layer. So V by 400 centimeter cube. So now we are going to calculate the thickness of that layer of the liquid. It is spread over on the water, that oleic acid. So now area equal to A, volume equal to V by 400. So thickness T equal to V by 400 into A. So this is the thickness of the layer. So using that we are going to calculate the thickness. Thickness means it's only one layer, that is equal to size of the molecule. So indirectly we are measuring the size of the molecule in this method. Okay. So next thing is, so by using that measurement, we can measure the distance between the two stars, star A and B, and we can measure the molecule size. So see, these are the some size of an object or the distance. So see that the initial thing from 10 to the power of minus 15 to 10 to the power of minus 4. These are all the smaller measurement which is used to measure the very smaller object like proton, nucleus, atom, virus, light, like that. Then 10 to the power of 4 to 10 to the power of 26 is the very larger values. These values are used to measure the radius of the earth, distance of the moon from earth, distance of the sun from the earth, and distance of the Pluto from the sun, then size of our galaxy, size of an Andromeda galaxy. Andromeda galaxy is the very close to us. That is the Andromeda galaxy. So these all the units are used to measure the very smaller and very large in size things. Okay. So by using that measurement, that length, we can measure a very greater distance. Then 1 F, that is 1 Fermi, that value is equal to 10 to the power of minus 15 meter. So instead of 10 to the power of minus 15 meter, we can say that is 1 Fermi. Next one is 1 angstrom. Then angstrom is equal to 10 to the power of minus 10 meter. So that is equal to 1 angstrom. Then 1 astronomical unit. That is 1 astronomical unit equal to 1.496 10 to the power of 11 meter. So 1 astronomical unit. That unit is used to measure the distance between the Earth and the Moon, then Earth and the other planets, like that. We can use the 1 astronomical unit. Then 1 light year. 1 light year equal to 9.46 into 10 to the power of 15 plus 15 meters. So it's a very large in value. That values are used to measure the distance between the planet to planet or galaxy to galaxy or constellation. So we are using these values for measuring in a very large distance in our galaxies. Okay, so that light year is used for to measure the very large distance. Then 1 PC, that is 1 pico, that is equal to 3.08 into the power of 16 meter. So this is also used for measuring a very large distance. So 10 to the power of 16.